In this video, we're going to talk about linear equations. But before we do that, we're going to start a bit more generally and talk about how we would solve just any type of equation. So we're going to start with an equation in one variable. Okay, that's exactly as it sounds like. It's an equation, so it has an equal sign. Okay, so this, maybe I'll just write that. Okay, so there's a difference between an equation and an expression. Okay, so equation has the equal sign, okay, whereas an expression does not. Okay, so an equation in one variable is an equation with an equal sign where there's one variable involved. Okay, often this is x, but it could be any letter. So sometimes we're able to solve for the variable. So what that means is that we're writing simpler and equivalent equations until the variable is isolated on one side. Okay, and the other side does not have a variable. So we have a variable on one side and numbers on the other side. Okay, so then the solution of an equation, so let me just write that. The solution of an equation is an admissible, I should say actually, let me just fix this, a solution. Okay, there could be more than one solution. So a solution of an equation is an admissible value of the variable that results in a true statement. So what I mean by that is when you plug it in, you get something that makes sense. Okay, so you might get an equation when you plug it in that says like 2 equals 2. Okay, so something that makes sense. That results in a true statement. Okay, then when we take all of these solutions, so the set of all possible solutions, of an equation is called the solution set. Okay, so for instance, the equation x squared equals 9 has two solutions, so 3 and negative 3. So when you plug in 3, we're going to have 3 squared, which equals 9, and that's a true statement. When we plug in negative 3, we're going to have negative 3 squared equals 9, which is also a true statement. Okay, so those are both solutions to this equation. So our solution set is a set contains both of them. So now I'm going to write here, so for sets, to indicate that we have a set, we use the curly brackets like you see there. Okay, so you want to use curly brackets when you're doing that. Now, to solve an equation, so to find the solution, what we want to do is manipulate the equation to make a simpler equivalent equation. So there's a bunch of different operations that we're allowed to do. So the first one is that we can interchange the two sides if we want. So for instance, 3 equals x is the same or is equivalent to x equals 3. Okay, so it doesn't matter if you flip the equation. Okay, you can always change the sides that things are written on. You can simplify or rewrite one side to an equivalent expression. So for example, something that you might want to do in that case, maybe I have 2 times x plus 3 in brackets equals, I don't know, x. So simplify one side. So here we would want to expand this maybe. Okay, so this would be the same as 2x plus 6 equals x. Okay, so you can simplify one side if you want. You can add and subtract the same number to both sides. Okay, so let me just, or to or from, both sides. Okay, so whatever you do to one side, you have to do the other side. So for example, if I had 3x minus 5 equals 4, and I want to get the 3x by itself, I might add 5 to both sides. Okay, so if I add 5, the minus 5 and the plus 5 becomes 0. And then this is going to be the same as the equation 3x plus 0 for the 5s equals 9, 4 plus 5. Okay, another thing you can do is multiply or divide on both sides again. Okay, so on both sides. Now there's another important word here. You have to do it by a non-zero expression. So you're never allowed to multiply or divide both sides by 0. So for example, if I use this equation above, if I have 3x equals 9, then maybe I want to divide both sides by 3. Or you could think about it as multiplying both sides by 1/3. Okay, that's a non-zero number. So this would be the same as, so 1/3 times 3 is 1. So this is going to be 1 times x. And 9 times 1/3 is just 3. Okay, so this is also just x equals 3. So see that doing that simplified the expression, and now I know the solution. Okay, another thing, just to give you another example here, if I had, say, I don't know, 3x over x minus 1 equals 6 over x minus 1. Again, I want to, if I want to get rid of the denominator, I might want to multiply both sides by x minus 1. Okay, now the problem here is, so the reason I might want to do that is, then this would go, it would, the x minus 1s over x minus 1 is a 1. Okay, so those actually cancel, and we simplify the expression to 3x equals 6. Okay, but this only works as long as x minus 1 is not 0. So another way to say that is x is not equal to 1. Okay, so I'm allowed to do that as long as x is not 1. So we're going to talk about in a minute what happens if we get a solution after where x actually is 1. Okay, so that's the idea. Those are the only things you're allowed to do to manipulate equations. Okay, now we're going to talk about just specifically linear equations. Okay, so a linear equation so this is in one variable for now. Okay, is an equation that can be written in the form a times my variable plus b equals 0. Okay. Now, because I want to have the variable, I want a to not be 0, so there is a variable. And we get what we call a polynomial. So the degree of the polynomial is 1. Okay, now what I mean by that is the highest power of x, or my variable, is 1. Okay, so I didn't write the power, so when the power is 1, we don't normally write it, but there is a little 1 there. Okay, so that's the degree when it's the highest power. So let's see an example here. So I have 1/2 times x plus 5 minus 4 equals 1/3 times 2x minus 1. Okay, now here we know this is a linear equation since the highest power of the variable, okay, so that's x, is 1. Okay, now we're hoping that it can, so basically we want to rewrite this and solve for x. Okay, so I guess I should write here, can be manipulated to the form ax plus b equals 0. Okay, and I guess this is assuming the x's don't cancel, which they could. Okay, so let's actually try to solve this. Okay, so each time I write an equivalent expression, I'm just going to use an arrow like that. Okay, so this equation here is going to be equivalent to the one I write here, and then we're just going to keep simplifying as we go down. Now you don't want to write equal signs because there's already an equal sign, so each equation is going to have an equal sign in it. So if you write equals here, it's going to be confusing, so we normally write an arrow. Okay, so we know this is just we're doing this, and then we're simplify to get this, okay, etc. So the first thing I'm going to do for this equation is simplify each side. Okay, so I'm going to factor in or expand the 1/2 in and also the 1/3 in. Okay, so when I do that, I'm going to have 1/2 times x plus 5 over 2 minus 4 is equal to 2 over 3x minus 1/3. Okay, so now we did that. So now I want to get the x's on the same side. Okay, so whatever side you want, it doesn't matter. Okay, so I'm going to move this x over. So to do that, what I'm going to do is subtract 1/2 x on both sides. So notice I wrote that on both sides, because then 1/2 x minus 1/2 x, this is going to be a 0. Okay, so that means there's going to be no more x's on that side. Okay, so I still have 5 over 2 minus 4 is equal to, and now I have 2/3 x minus 1/2 x. So maybe we'll just write over here. So that means I need to combine these fractions. Okay, so I have 2/3 x's minus 1/2 x's, so I'm going to have to make a common denominator here. So it's going to be over 6. So I'm going to have to times the first one by 2 over 2, so I'm going to have 4 over 6. And the second one I'm going to times by 3 over 3, so I have 3 over 6. So I'm going to be left with 1 over 6. Okay, so here I'm going to have 1 over 6 x's minus 1/3. Okay, now again, I want to get these x's by themselves. Okay, there's only one here, so what I'm going to do is move this to that side. So to do that, because it's minus 1/3, I want to add 1/3 to both sides. Okay, because then the negative 1/3 plus 1/3 is a 0. Okay, so then my next step, I have 5 over 2 minus 4 plus 1/3 equals 1 over 6x. Okay, now in the next step, I'm just going to combine. These are all like terms, right? I'm just going to combine them all. So again, I need to make a common denominator. Maybe let's do that over here again. So 5 over 2. So my common denominator, again, is going to be over 6 because of the 5 and the 2 and the 3. So I'm going to times by 3 over 3, so that's going to be 15 over 6. Now this is like over 1, so I actually have to times it by 6 over 6. So it's going to be 24 over 6. And then I have 1/3, I need to times by 2, so that's going to be 2 over 6. So if I put all the tops together, I have 17 minus 24. So that's going to be 17 minus 24. I think that's negative 7 over 6. Yeah. Okay, so that side here is going to be negative 7 over 6 equals 1 over 6x. Now again, I want to get the x by itself, so now what I'm going to do is multiply both sides by 6. Okay, now negative 7 over 6 times 6, that's negative 7. And 1 over 6x times 6, that's just x. So you see, I get my solution. Okay, so that's going to be a solution. Now we should check this. So let me just change colors here. Okay, so if I plug in negative 7 everywhere, so 1/2 times negative 7 plus 5 minus 4 should equal 1/3, 2 times negative 7 minus 1. Okay, so this is 1/2 times negative 2 minus 4. And over here I have 1/3 times negative 14 minus 1 is negative 15. So 1/2 times negative 2 is negative 1, minus 4, that's negative 5. 1/3 times negative 15 is also negative 5. So you see I get something true. And in fact, this is the only solution. Okay, so to solve equations with fractions, you can, and like I said, you don't have to, but you can first multiply both sides by the product of all the denominators. So you're multiplying by the least common multiple of the denominator, or you could multiply by the least common multiple of the denominators. So now what I mentioned above, when you, if you had to multiply by something like x minus 1 on both sides, where there's an x that can't happen, if you get that as your solution, but it can't actually happen, we call that solution extraneous. Okay, so an equation can never have an extraneous solution as a solution. So we want to remove those from the solution set. Okay, so let's try this example and see how that might happen. So here's our equation. So the first thing we could do is multiply both sides by x minus 1. That's the only denominator here. Okay, now here we want to be careful that we can only do this if x minus 1 is not 0. Okay, so we want to make a note of that just to make sure that we don't forget. So when we do that, you're going to have to expand this into both these terms. Okay, the 3x times x minus 1 over x minus 1. If x minus 1 is not 0, that's just 3x. So this x minus 1 is going to cancel with that x minus 1. Okay, and then I'm going to have plus 2 times x minus 1. And again, on this side, the x minus 1 is going to cancel. So I'm just going to be left with a 3. So we simplified our equation quite a lot there. Okay, now we just want to expand. So 3x plus 2x minus 2 is equal to 3. So this is 5x when I put the x's together. Okay, and then I could add 2 to both sides to get rid of that 2. Okay, so now I'm going to have 5 on that side. And then I can times both sides by 1/5 or divide both sides by 5. And I'm going to get x equals 1. Okay, now that's my solution. Okay, so this would be our solution. But if we check it, and we plug in 1 to the initial equation, oops. So I get 3 times 1 over 1 minus 1 plus 2 is equal to 3 over 1 minus 1. This is the same as 3 over 0 plus 2 equals 3 over 0. Now, can we divide by 0? I hope that everyone is comfortable with the fact that we cannot. Okay, so this is bad. So that means that x equals 1 is not actually a solution. And remember that the solving we did, we could only do if x minus 1 was not 0, and it is 0 when x equals 1. So this is not a solution. So this equation, this equation actually has no solutions. Because the only solution that's possible is an extraneous one. Okay, so we actually have no solutions there. Okay, let's do one more example here. So Jeffrey is taking a course where his grades consist of 3 midterms, each worth 20% of the final mark, and a final exam that's worth 40. Jeffrey scored 88, 79, and 83 on the 3 midterms. What grade does Jeffrey need to get an A, so 85 or better overall? So here we need to set up an equation. And it turns out that we're going to have a linear equation. So if each midterm is worth 20%, then we're going to take his 88% and we're going to take 20% of it. So what you do is you times by 0.2. Okay, so this is the decimal version of 20%. Okay, and then we're going to do that for the 79 that he got on test 2, also times 0.2. And we're going to do the 83 that he got on test 3, also times the 0.2. And now we don't know, oops, sorry, I didn't want an equals there. We don't know what he scores on the final. Okay, but we do know it's worth 40%. Okay, so that's how you're going to compute his final grade. And you want it to be at least 85. So let's just make it equal to 85. And then we know if he does better than what the x we get, that he'll get a higher grade. Okay, so this is going to give us the minimum x that he needs. Okay, so then if I simplify each of these, so 88 times 0.2 is 17.6. Okay, 79 times 0.2 is 15.8. And then I have 16.6. And then I have my 0.4x, and I want that to equal 85. Okay, so putting all these things together, if I add those up, I actually get 50. Okay, so that's just putting these guys, oops, I didn't want to do that. I wanted it like that. Okay, so putting those together gave me 50. So I want to solve for x. So I'm going to subtract 50 on both sides so that the 50 goes away. So that's going to give me 0.4x on this side and 35 on that side. And then I could divide by 0.4 since it's not 0. And that's going to cancel it on this side. So that's going to give me my x, and 35 divided by 0.4 is 87.5. Okay, so that means that Jeffrey needs to score, at least 87.5% on the final to get an A in the course. An A or better, let's say. Now I'm going to leave this last example for you to try, but I will post it filled in for you. So give that a shot. You just have an equation and you want to solve for R. This equation happens to be, it gives how much money is in an account, paying R% simple interest Okay, you don't really need to know what that is, but if you do, that's good. Simple interest for t years. Okay, when P dollars is invested initially. Okay, so that's what it's doing. So what it's asking you to do in this question is solve for R. Okay, so you want to rearrange this equation so you have R equals something. And obviously it's going to depend on A and P and T. But because this is a linear equation, all the variables have power 1. You should be able to arrange it using the tools that we had. So that's really good practice. It's a tough one though, so you might want to do some extra practice before you try that one.